Hi students, welcome to my YouTube channel, Fun with Chem. Today we are going to discuss May 2025 Unit 4 MCQs. So we'll see the first question. This is about carbonyl compounds. So before answering this, I want you all to know something that you should know, right? If it is alkanes children, all alkanes will undergo only free radical substitution reaction. If it is alkanes or alkynes, they will undergo electrophilic addition. If it's benzene, they will undergo electrophilic substitution. If it is alkyl halides, they will undergo two reactions. One is nucleophilic substitution. The other one is known as elimination. Fifth one, alcohols. They also will undergo nucleophilic substitution and elimination. Then we have aldehydes and ketones. They will only undergo nucleophilic addition. Then carboxylic acids and its derivatives like esters, amides, right? They will undergo nucleophilic substitution. So all the organic compounds, they will undergo different types of reaction like this based on their functional group, right? So proper known, it's a ketone, right? So as I said, ketones will undergo nucleophilic addition. So the correct answer is C. So you all better write this down because this is like the basic thing you should know when determining reaction type of a given reaction. Then we'll see the next one. What is the step in the mechanism of the reaction between propanone and a mixture of HCN and KCN? First step, right? Okay, so I will erase it. So if I draw propanone, when we have HCN, KCN children, remember that HCN is a weak acid. Therefore, it partially gives cyanide to the medium. But when we have KCN, it's a strong electrolyte. So you have cyanide ions in the medium because of KCN. Therefore, we have cyanide ion. And remember that the lone pair should be on carbon. Then we need to find the polar bond. We know this is the polar bond in carbonyl group compounds. Therefore, the more electronegative atom will attract the bond pair electrons. Therefore, the carbon becomes partially positive. So, the lone pair will attract the partial positive carbon and it will form something like this. You have a lone pair oxygen, CH3, CN. When you have HCN, the lone pair will attract the hydrogen. So as a result, you get the hydroxynitrile and cyanide. So the second cyanide is coming from HCN. First cyanide is coming from KCN. If I write the name of it, I can write it as 2-hydroxy because according to the alphabetical order, H will come first. 2-hydroxy, 2-methyl propane nitrile because the carbon containing the nitrile will become 1 2, 3. I have 2 functional group. Therefore, the name is written like that. So we saw the first one. In the first step, we'll see what they have given, right? This is the first step. Lone pair of electrons on the carbon attacking the carbonyl carbon positive of propanone. So that's the correct one. The lone pair attracted the carbon positive one. Others are wrong. Then we'll see the next one. What is the name of the organic product? So I already told the name. 2-hydroxy 2-methyl propane nitride. So the correct answer is D. Which of these carbonyl compounds would produce a pale yellow crystals when warmed with iodine in the presence of sodium hydroxide? So children, remember that this is the iodoform reaction. Iodoform reaction is positive when you have a methyl ketone, something, a group like this, or when you have a secondary alcohol with a methyl group. For these two, it gives a positive result. So if I take butanone, it is written like this. So we can see there is a methyl ketone in butanone. If you take butanal, it is CH3, CH2, CH2, COH. It has a propyl ketone. So it will not give a yellow precipitate because this group is present only in butanone. Pentan-3-on, it is a ethyl ketone. Therefore, that will not give a precipitate. 2-methyl-propanal. So propanal means an aldehyde. 2-methyl means on the second carbon, I have a aldehyde group. So that is also not a methyl ketone. Butanone is the one that contains a methyl ketone. So it will give a positive result with iodoform. What is the formula of the pale yellow crystals formed in part D? So children, if I explain this reaction, we have butanone, CH3CO, CH2, CH3. When you add sodium hydroxide and iodine, this bond will break. The methyl one will be converted to triiodomethane, CHI3. It is a yellow solid. And the other part, as it's a basic medium, you get a salt of the carboxylic acid. So it's sodium propanoate. This is how the bond will break. And this reaction can be used to reduce the number of carbon atoms in an organic compound. So the correct answer is CHI3. The name is triiodomethane. CHI3. Which of these statements about the reaction of ethynyl chloride and ammonia is not correct? So first I write the products. Ethynyl chloride has a structure like that with ammonia, right? You can get ethanamide and HCl. Again, another ethynyl chloride can react with this ethanamide to form CH3CO NH COCH3. Right? Likewise, again, ethanol chloride can react with to form all the reaction will take place until you get a quaternary amide. It's like this: COCH3, COCH3, COCH3 and COCH3. So we'll see which is not correct. An amide is formed. Amide group is when a carbonyl group is connected to a NH2 group. That is correct. The reaction is exothermic. You can see new bonds are forming. That is also correct. Misty fumes and white smoke are given off. That is also correct because if you have ammonia and HCl in the medium, both of them can react to form ammonium chloride. That will form a white smoke. Misty fumes are due to HCl. A gas is produced that turns damp red litmus blue. The gas that turned damp red litmus blue is ammonia, but we can see ammonia is not forming. Therefore, D is wrong. Which of these substances would be expected to have the greatest standard molar entropy? So normally we know the greatest standard entropy is high with the increasing number of electrons. So if you take the electrons of the first one, atomic number of iron is 26 and oxygen 8, you have 34. 26 and 16, it's 42. Then 26 and 17 into 2, it's 60. 26 and 3 17s, 77. So the one with more number of electrons will have the greatest standard molar entropy. The answer is D. What is the pH of 1.25 solution of hydrochloric acid? So when we find the pH of an acid, this is a strong acid. First, you need to write the ionization. H plus and Cl minus. If it is 1.25, H plus concentration will also be 1.25. Then pH is given by minus log 1.25, which is equal to minus 0.097. So the correct answer is B. Then the next one, at 25 pH, the pure water is 7, and at 75, the pH is 6.4. So that means, children, you can see with increasing temperature, the pH has reduced. That means it is becoming acidic. Why is the pH of pure water lower at 75 than at 25? Because we know ionization of water is endothermic. It's an endothermic reaction. So if you give more heat, what will happen? More H plus will be formed. And there is an inversely proportional relationship between H plus concentration and pH. When H plus is high, pH is low. That means at high temperature, more H plus is forming, right? So we see the answers. There are more hydrogen ions than hydroxide ion when the water is at 75. That is wrong. Even though pH is 6.4, water is not acidic as it contains equal amounts of H plus and OH minus. Otherwise, when we boil water, what will happen? We are drinking acidic water. That is wrong. Even though the pH is low, the solution is neutral as it is having equal amount of H plus and OH minus. The dissociation of water is endothermic, so the concentration of hydrogen ion is lower at 75. That is also wrong. If it is endothermic, with increasing temperature, more H plus is forming, right? So the correct answer is C. Dissociation is endothermic, so the concentration of hydrogen ion is greater. But because of this inversely proportional relationship, pH is lower, right? This is not exothermic. So the correct answer is C. The sodium hydroxide solution with pH 12 is diluted by a factor of 100. Okay, so pH 12 means H plus concentration is equal to 10 to the power minus 12. So we know 10 to the power minus 14 is equal to H plus and OH minus. So we need to find the OH minus concentration. From 10 to the power minus 14, if you subtract 10 to the power minus 12, we are getting it as 10 to the power minus 2. That's the concentration of OH minus in this solution. When we are diluting by a factor of 100, that means we need to divide it by 100. So you get it as 10 to the power minus 4. That is the new concentration of OH after diluting. Then if I apply to this equation, 10 to the power minus 14 is equal to H plus, we have to find in order to get the pH. Then I'm getting H plus as 10 to the power minus 10. pH is equal to minus log 10 to the power minus 10. So you get the pH as 10. So the correct answer is A. So remember that pH is always given for H plus, but this is a basic medium. So we need to find the concentration of OH minus. Then only we need to find diluted concentration. Then again we need to apply ionic product of water to find the H plus after the dilution, then the pH. Hi, this is very easy. They have given this peak, which compound is X. So if I take first one, the molecular formula is 1, 2, 3, C3H 3, 4, 5, 6, 7, 8, and O. So you can find it easily. 12 into 3 is 36. We have to take all 4 decimal places. And 8 into 1.0078, which is 8.0624, then 15.9949. So if I add all, I'm getting 60.0573. That is not exactly 60.02. So if I take the second one, it's C2H4O2. C2 means we have 24, 1.0078 into 4, which is 4.0312. Then 15.9949 into 2, which is 31.9898. Then if I add everything, I'm getting 60.021, which is exactly equal to the one they have given. So the correct compound is X. X is acetic acid. Answer is B. Eighth one, a thin layer chromatography of a substance is shown, but it's the RF value. To find these children, we need to measure the distance from the starting point to the position of sample and the distance from the starting to the solvent front, because RF is given by distance traveled by the ink or sample divided by the distance traveled by the solvent front. So you can use a ruler to find this distance. When you measure it, you get an answer closer to 0.73. Then ninth one, in an experiment, determine the rate of a reaction between bromine and methanoic acid. Which method would not be suitable? Quenching and titrating with an acid. So we can see children, H plus is using, H plus is in the medium. So if you use an acid for the titration, nothing will happen. If you are using titration, you have to titrate with a base only to find the H plus amount. So that is the wrong one. Loss in mass, that is correct because carbon dioxide is forming. Colorimetry you can use because bromine is a colored solution. Volume of the gas also you can use because carbon dioxide is formed. Only But if they mention quenching and titrating with a base, that's correct, but not an acid. The reaction shown is second order with respect to NO and first order with respect to O2. So if I write the rate equation, rate is given by second order with respect to NO and first order with respect to O2. If the concentration of NO is doubled, okay, so if I'm doubling the concentration of NO and oxygen is tripled, then we know this is 4 times and this is 3 times, then you will get it at 12 times, right? So the correct answer is B, because always remember when you multiply it by 2, as it is second order, you take 2 to the power 2, which is 4. And this is 3 to the power 1, which is 3. So 4 into 3, it's 12. Then the 11th one, a chloroalkane undergoes hydrolysis according to the equation shown. The rate equation is given, which chloroalkane is most likely to be RCl. So children, in this halogenalkane, you have only 2 types of rate equation. One is with only the halogenalkane, the other one contains RCl and OH. This rate equation is there for a primary halogenoalkane, primary and secondary. Both can take the same mechanism. But this is only formed for tertiary and secondary, right? So out of these 4, we have to find which is a tertiary halogenoalkane. So this is a primary halogenoalkane. B is the only tertiary one. C is a secondary one. D is also a primary one. Therefore, the correct answer is B, as it is tertiary. Even though they have given a secondary one, but remember that secondary one can take both mechanisms. But when they give it only, when they give only the thing, it is only for a tertiary halogenoalkane. So why we can't take the secondary halogenoalkane, as it can undergo both rate equation, KRCl and KRCl and OH. But when you have tertiary halogenoalkane only, you can have this rate equation. So if you take the 12th one, this question is about the titration curves obtained by reacting different acids and alkalis of the same concentration. Which curve is produced by ammonia and hydrochloric acid? So children, there's another theory part you should know. When you have a weak base, right, the reaction will start or stop at 10 to 11. Adding ammonia to HCl means ammonia is in burette. HCl is in the conical flask. Therefore, we can easily omit 2 and 4. And if you have a strong acid, the pH is between 1 to 2. Therefore, you can see in the first curve, it has stopped at 13 to indicate that it's a strong base. But in the third curve, it has gone until 10, right? So to indicate that it's a weak base, strong acid titration. So the correct answer is curve 3. And if you have a weak acid, like acetic, it will start above 2. If you have a strong base, it will stop at 13 to 14. So without knowing this, you can't answer these type of questions. This is a theory part you should know to answer this. Which of these indicators would be more suitable to determine the end point? Now children, our reaction is HCl, ammonia forming ammonium chloride. This is a weak base. This is a strong acid. When you have a strong acid and a weak base, the equivalence point will lie in the acidic region as it is strong. So if we take Congo red, we can see 3 to 5. Sorry, which of these indicators would be more suitable to determine the endpoint for the titration that gives curve 4? Okay, curve 4, we can see that it has stopped at 3 to indicate that it's a weak acid. It has started from 13 to indicate that it's a strong base. It's like sodium hydroxide and acetic acid. So therefore, the equivalence point will have a basic pH. This is acidic one. Again, this is an acidic one. This is too basic. So the correct answer is 8 to 9.6. We have 4 types of titration: strong acid and strong base. For that, you can use any indicator because it has a range from 4 to 10. If you have strong acid and a weak base, it will be less than, it's starting from 2 to 6. If it's a strong base and a weak acid, it will start from 8 to 10. If it's weak acid and a weak base, you can't use any indicator as it doesn't give a sharp endpoint. You can use a pH meter to find the pH at the equivalence point. So the correct answer is C. It should be between 8 to 10. Then the 13th one, which is expression for the equilibrium constant. So when we write Kp, children, it's always the partial pressure. Therefore, we don't use square brackets. We use partial pressures like this: PSO3 to the power 2 divided by PSO2 to the power 2 and PO2. So the correct answer is like this. Also, we don't take stoichiometric ratios are written as powers when we write equilibrium expression. So the correct answer is, so we always write products over reactants, not reactants over products. So that's why D is wrong. Then which statement about the equilibrium is correct? So we can see increase in the pressure increases the value of Kp. Kp is given by products over reactants. Here 3 moles and 2 moles. Pressure is high on the reactant side. So when you increase the pressure, system will try to increase more products. Therefore, increase in the pressure increases the value of Kp. So remember that Kp will only change when we change the temperature, right? So here, even though at the beginning, when products increase, Kp increases, but at that time, we introduce it as Qp, right? Reaction coefficient. So Qp will finally become Kp. Therefore, there's no change when we increase the pressure or when we increase the temperature, when we increase the concentration or when we add a catalyst. Kp depends only on Kp and Kc depends only on temperature changes. Therefore, nothing will happen. Decrease in the pressure decreases the equilibrium yield of SO3. So when you decrease it, that is correct, right? Because system tries to form more reactants to increase the pressure. So that is the correct one. So remember, children, equilibrium position and Kp are not the same. Now, when we increase the pressure, position of equilibrium will move towards your right-hand side. But that will not increase Kp because Kp or Kc depends only on temperature. So the correct answer is B. What is the relationship between the equilibrium constant and total entropy? It's directly total entropy is equal to R, L, and K. So the correct answer is A. Right. So children, I just want to discuss only the MCQs as only the answer is there in your marking scheme. The structure is a part you all can easily go through with the marking scheme. So yeah, so thank you for watching. Like and subscribe my channel, children, right?